So for this video, we're just doing a little bit of homework help on the acceleration problems. So if you're stuck and not sure what to do, this is a great place to be because we are going to go through a couple examples to help you out. So for the first one here, we're just going to go through a couple of them. I'm going to try and go through one of each version of the equation, so then you kind of know what your equation should look like. So let's do the first one. We've got to calculate the acceleration of a car that goes from 30 meters per second to a speed of 65 meters per second in 5 seconds. So our acceleration equation is A equals V final minus V initial over time. And we're looking for A. Our V final, well, this is 65 meters per second because that's what it was going to. So that's the speed that it needed to get to in the end. Our V initial, this is the 30 meters per second. This is what he started out at. And then our time, this is 5 seconds. So let's set this up in the equation. It's A equals 65 minus 30 over 5. So our acceleration for this problem should be 11.67 meters per second squared. So that is how you are going to set up the problem. All you have to do for this problem now is just do the math. Alright, so let's take a look for another one. Let's do number 3. So this one we are looking for the change in velocity. Alright, so an object falls from a skyscraper and hits the ground after 5 seconds. The acceleration of the object is due to gravity. The acceleration of the object due to gravity was 10 meters per second squared. What was the change in velocity? So the easiest equation for this one is the A equals delta V over T. Because remember, VF minus VI gets you a change in velocity. And so this equation just shortens that. It just says a change in velocity over time. So we're going to use this one so that we can figure out the change in velocity. So to rearrange the equation, you're going to multiply both sides by t, and then you're done. So delta V equals A times t. Alright, so now let's figure this out. We're looking for delta V. We know our acceleration was 10 meters per second squared, and our time was 5 seconds. So if you set that up in the equation, it's gonna look like this. So that's what it should look like. All you have to do for this problem now is figure out the answer. And then let's do number 4 here, because this one is looking for time. So Billy Bob's four-wheeler will accelerate at 3.0 meters per second squared. If Billy Bob starts from a stop and reaches 21 meters per second, how long does it take him to reach this speed? So we're gonna again we'll use V final minus V initial over time for this one. And now we need to rearrange this for time. So we're gonna multiply both sides by t, and now our equation looks like this. But we still need time by itself. Now our equation looks like this. But we still don't have time by itself. So we're going to divide both sides by A, and so now our equation should be T equals V final minus V initial over A. Alright, so I'm going to erase this stuff so I have a little bit of room here. So for this one, remember, we are looking for time, so we don't know that. But we know the V final, which is he reaches 21 meters per second. We know his initial speed, which was 0 meters per second because he started from a stop. And we know his acceleration, which was 3.0 meters per second squared. So we can set this up in the problem. V final, well, this is 21 minus 0 over 3.0. All right. So there's your setup. Now all you have to do, again, for this problem, just like the others, is do the math to get your answer. So I went through and did 3 problems that you are going to need to rearrange equations for. Hopefully this helped you out a little bit. If for some reason you still have questions because you are just completely stuck, please send me an email or a text message and I can help you out. Otherwise, have fun calculating acceleration.